they use exactly that law of motion for the capital stock to say, okay, we have data on investment activity in past years from national accounting, and so we can actually derive the current capital stock as the sum, the discount, or the discounted sum of all past investment activities plus something which may be in the very distant past. Right? If you have 50 years of data, this might be J goes from 0 to 50. Let me see. I made a mistake. I think this should be T plus 1. I'm sorry about that. This wasn't a mistake. Now, the nice thing is, suppose you're not sure how much capital you had in the very distant past. The good thing is it doesn't matter so much because you're taking 1 minus delta to the power of t plus 1. So take 0.9 to the power of 50. It's almost 0, right? So making a mistake for the initial condition doesn't matter so much. And so that's how how capital is measured in practice. And so, you know, we can get data on the capital stock in different countries, and it's quite interesting to see. And what's behind it. Of course, there's much more to be said about the capital stock. Quality of the capital stock matters, and many other things matter. But by the end of the day, there is a way to measure this. So, last thing before we go into the stuff that we meant to do, we assume that there's just one good that can be either consumed or used productively. So you have the computer, which can either be used for watching Netflix videos or used productively in a company. Of course, some goods satisfy this constraint. I mean, the potato can either be eaten or can be put into the soil. But for other goods, you could argue, look, the chocolate bar is something that you can consume. You cannot invest it. Now, we abstract from that. We just say we have a costless transformation of consumption good into physical capital, right? That is, of course, something that when you see it for the first time, you find a bit weird. In fact, you have to step back to see the problem. But of course, there is a thing, and the other thing is, capital stock cannot be varied within the same period. And this will later be important. So we have the capital stock is a stock variable. So you wake up with the capital stock at the beginning of period S. And then you may realize, damn, it's too low. Or you may realize, damn, it's too high. But you cannot change it. You can change it by doing investment, and then you change the capital stock in the next period, right? It's very, now, of course, this depends on how you define the periods. I mean, you could argue a period is a quarter, then that's quite reasonable, right? You cannot dismantle the machines within the period, or build new machines, so it takes time. That's the time to build constraint. But that's something that we have to be aware of in discrete time models. The capital stock at the beginning of period S is given. You inherit it from the past. And you can, of course, vary the capital stock in the next period, but that's something that takes time, right? Good. So, what's the representative consumer's maximization problem or optimization problem? Well, the representative consumer chooses the time path of consumption and investment to maximize this utility function, right? That's the infinite horizon model again, subject to a lot of constraints. First constraint is the one that we saw yesterday with a few novel ingredients. The first ingredient is output is no longer exogenous. Output is produced using capital and labor. Note that labor is not time variant. Second thing, you subtract not just government spending from output and growth returns on the NIIP, but also investment. Investment is new, right? We didn't have that in the endowment economy model because it was not necessary. Now, come back to the coconut example. Now, the representative consumer can affect the number of coconut trees. And he or she can affect the number of coconut trees by taking coconuts and instead of eating them, putting them into the ground. That would be the investment, right? That would be, you invest, and that turns into, that affects the capital stock, and the capital stock produces coconuts, right? We assume that at time t, when optimization takes place, BT is given and the capital stock is given. So every day you wake up, you do the optimization, but you do the optimization knowing that the capital stock is fixed and the net international investment position is fixed. You inherit it from the past. Good. So let's roll up our sleeves, and I already did. And let's solve the whole thing. Or solution means characterize the optimal time path of consumption and investment. Now, there's various approaches, as you know, to solve an intertemporal optimization problem. There's the sophisticated and elegant approach and the quick and dirty approach. And I'll use the quick and dirty approach, meaning that I'm substituting the constraint into the objective function. Now, this is a long thing, right? Now, let me turn to this blackboard, and I hope you can see what I'm writing. I'll try to write in large letters. And I have to endow myself with a lot of pens, but I do have a lot of pens. So maximize ut, which is the sum of s going from t to infinity, beta to the power of s minus t, ucs, subject to bs plus 1 equals as f KSL plus 1 plus R BS minus consumption minus government spending minus investment. So you have output that generates an income. You have income which is possibly positive or negative depending on the NIIP from the previous period. You subtract consumption, you subtract taxes, which with a balanced budget coincide with government spending, and you subtract investment. And you have that other constraint which says Ks plus 1 equals, well, let me first, sorry about that, don't copy. So that's of course equivalent to saying Cs equals just ASF KSL plus 1 plus R BS minus GS minus IS minus BS plus 1. Right? We've just moved the CS to the left-hand side. We've moved the BS plus 1 to the right-hand side. Now the second constraint is Ks plus 1 equals 1 minus delta Ks plus Is, which is equivalent to saying Is equals Ks plus 1 minus 1 minus delta Ks. Now, we substitute this thing in here. And combining both And I know that the red pen is not so good because it's hard to erase afterward, but I think there's also an advantage to using an additional color. So you have CS equals AS F KSL plus 1 plus R BS minus GS minus KS plus 1 minus delta KS minus BS plus 1. Yeah. Okay. Okay. Now, consumption is output plus 1 plus R times the initial net international investment position, assets minus liabilities, minus what you have to give to the government, minus the capital stock of the next period, plus 1 minus delta, the capital stock that you start with, minus the net international investment position of the next period, at the beginning of the next period. Please note, the way we write down this problem allows for the possibility, and that I have to say that because it's weird, but allows for the possibility that you know, there's a machine, the computer,